Today I'm going to share with you a simple tutorial in C# where I'm going to show you how to develop a simple fingerprint capture application using the ZKTeco type 4500 fingerprint scanner. So let us get started. So the first thing I'm going to do, I am going to launch Visual Studio. So I'm using Visual Studio 2022. So now let me open the Visual Studio right away. So I'll just come here at search and type Visual Studio. Here it is. So I just click on this. So my Visual Studio IDE is launching. So let's give it a moment. Here is the app that I want to show you. So I'm just going to click at this ZKTeco 4500 simple console application that I developed. So it is opening. So it is taking a while, but it's going to be ready in a moment. So I can see that it is actually loading the editor. It says loading document contents. There it goes. So now the Visual Studio IDE is now ready. So now I want to show you how I was able to code this simple fingerprint capture application using C#, and the device that I used for fingerprint capture is the ZKTeco type 4500 fingerprint scanner. Please let me know in the comment section which other ZKTeco device you have been able to use in the past, and what applications have you been able to develop with it. So to get us started, I would like to show you how I was able to break down this application into some 10 steps that I was able to follow so that I could be able to capture fingerprints with these in this application. So the first thing that I would like to show you is those sections that I am calling steps. I should be calling them sections. So I will just scroll right here to this section here. I'll be able to take you through the rest, but I first want to show you these sections that I was able to follow through so that I can be able to capture the fingerprints. So the first one is initialize the ZKTeco and get result outcome value. The second one is get count of the connected devices. The third one is to open the fingerprint scanner. The fourth one is to get the fingerprint scanner image width and height dimensions. Let's go to the fifth one. So the fifth one was to allocate fingerprint buffer and fingerprint template buffer. Though in this demo, in this tutorial, I won't delve deep into the template buffer. I will just show you how, I will just concentrate on the fingerprint buffer. In another episode, I'll be able to show you how to retrieve the fingerprint template. So this bit for fingerprint template buffer, I will handle it in a future episode. So for number 6, I will show you how to capture the fingerprint image. Then we'll later on go on to step 7, where I will show you how to display the captured fingerprint image. Now, for your app to be able to run efficiently, in your app you also need to close the fingerprint scanner, and you also need to free the resources for the fingerprint scanner API. So in that case, to close the fingerprint scanner, we'll be able to achieve that in step 8, and to be able to free the ZKTeco API and the SDK resources, we'll be able to do that in step 9. Now for section 10, here I'll be able to show you the functions that I was able to use to achieve all of these steps, namely from step 1 to step 9. So this section 10 is the one where I show you those functions that I was able to call and be able to achieve those objectives in the various steps from number 1 all the way to number 9. So let us get started right away. The first thing I need to show you is how the app runs. So the first thing I'm going to do is I'm going to first clean the app. So I come here at build, then I click on clean ZKTeco. So observe here what happens here at the bottom. So I was able to clean the app successfully. Now the other thing we need to do is to build the app. So I come here at build, then I click build ZKTeco 4500 simple console application. So now the application is building. So waiting for the application to build so that we can proceed. So the app was built successfully, so there were no errors, as you can see. Now what I'm going to do is that I'm going to run the application, then present a finger on the ZKTeco 4500 fingerprint scanner so that you can see how the app works and you'll be able to see the app capture a fingerprint image and display it on the screen. So to do this, by the way, just in case I forgot to mention, the ZKTeco 4500 fingerprint scanner is already connected via USB to my development computer. Sorry. Also now I'm going to click on this to run the app. So I hope you stay vigilant and observe what happens, and then you'll also be able to see me present my finger on the scanner and the application capture the fingerprint and display it on the computer. So we go straight away and I click this. So as you can see, the application is requiring me to present a finger on the scanner. So I'm going to present my left index on the fingerprint scanner. So there goes my fingerprint image that was captured when I presented my left index on the ZKTeco 4500 fingerprint scanner. Now I will need to minimize this image. But in the code I will also show you how I was able to display this image, the captured fingerprint image from my code. But the first thing I want to do is to show you what transpired in the background. Then later on I'll be able to show you how this was possible from the code. So I will minimize this so that we can go to the console. So that I can be able to explain a few things there before I take you to the code. So I'm scrolling all the way to the top. So when you run the app, the first thing that the app does is to initialize the ZKTeco Fingerprint API, and once it does that, it tells you whether it was a success or whether it was a fail. So as you can see right here, there is this value that I'm calling ret ZK init API. So if it returns a 0, that means it is a success. So in that, if you receive a 0 when you're initializing the ZKTeco API, that means you are able to successfully initialize the API. Now the second step is to get the count, the number of connected ZKTeco fingerprint scanners. So if it is anything below 0, if it is anything below 1, the application does not proceed any further. So in our case, because there was a ZKTeco fingerprint scanner that was connected via USB, we were able to receive this message here, that is number of connected ZKTeco fingerprint scanners is 1. So if the app is able to get at least 1, it proceeds to the next step. So the other step after getting the count of connected fingerprint scanners, if at least there is one ZKTeco scanner, is to open that ZKTeco device so that we can be able to capture fingerprints with it. So that's why you see this message here, opening ZKTeco device, success. So this means that we were able to successfully open the connected ZKTeco device. Now the other step, that is the fourth I believe, is to get the width and the height of the image that will be produced by the connected and opened ZKTeco device. So in our case, because we are using a ZKTeco 4500, it was able to retrieve the width as 292 pixels and the height is 374 pixels. Now once all these steps are met, the device now begins to anticipate for you to present a finger on the platen area of the fingerprint scanner. That is the area that is glowing green, the area with the green LED light. That is where you place your finger on the scanner. It is called the platen area. So as the device waits for you to present your finger on the scanner, it continues to run this message: place finger on ZKTeco 4500 reader to scan. So it continues to show you this every half a second as it waits for you to present your finger on the scanner. Actually, if you don't present this message, will just run and run, continue running until you present your finger on the ZKTeco scanner. So at the moment I was able to present my left index on the scanner, and the scanner was able to capture the image successful. The application returned this message, that is, fingerprint capture is successful. Now, immediately after the code logic determines that the fingerprint was successfully captured, it goes on to display the fingerprint image. So that's why you saw this message here, displaying fingerprint image shortly. So this message is first displayed before the application displays the captured fingerprint image. This one here, the one that you saw, if you remember before we minimized it, it was displayed immediately after this message was displayed on the screen. Now that I've been able to show you how the application runs and show you the messages that you interact with from the application, I now want to take you to the back end of the application so that I can show you how I was able to achieve that as we explore the code together. So are you ready for this? So okay, let me open the Visual. Let me go back to the Visual Studio IDE, then I show you the code. Here we are. This is the code on the Visual Studio IDE. Now the most important things are these steps that you see here: step 1, step 2, step 3, step 4, step 5, step 6, step 7, step 8, and step 9. So let us start with step 1. So in step 1, I need to initialize the ZKTeco API. So to do this, I will run this function here, initialize ZKTeco Finger SDK. So let me double click on it and then click Ctrl F so that I can show you, so that we can go to where this code is. So that we can go to where this function is. Then just go straight to see how this initialization is done in the init ZKTeco Finger SDK function. So let's go there. So right here is this function. The first thing it does is to call this bit right here. Oh, by the way, just before I confuse you, this bit here is used for checking whether there was a success in running whatever operation you are running with your ZKTeco API. So it usually returns a 0. So I created this variable here so that I can put the value from this right there. So basically this one returns a 0. That is what I observed, and it actually puts a 0 into this variable here. Now this bit here, that is this variable here, the int variable, is going to to store the output from running this ZKTeco API function, that is the init function of ZKTeco. Then if this bit here equals to this, is equals to this, then that way we know that our ZKTeco API was able to initialize successfully, and the output message is going to be ZKTeco initialization was successful, and then it will also give us the value of this variable here, and it is going to output it in the same line. So if I'm going to take you to the console, you'll be able to see this bit here that it returned, what it actually returned. So let me open this bit for you, then scroll here to the top so you can see. Sorry, it is this bit here. So the ZKTeco initialization successful, and then it shows you this variable here, ret zk init API returned as 0. So that is this bit here. So I think up to that far I've been able to show you how to initialize the ZKTeco API in step 1. So if the initialization was not successful, then the application would have returned this message here, ZKTeco initialization failed. But in our case that was not the case because it was successful. So that's why it returned ZKTeco initialization successful, as you can also see in the console right here in this highlighted bit here. Now let's go back to our code so that I can show you step 2. So step 2 is about where is our step 2? Yeah, step 2 is about getting the count of the connected devices. So I have this variable here that I created here. I pre-initialized it with -99. You can just put any figure that you want, but let it be something. Don't put a -1. Let it be something that is okay, how do I say it? Something that is lesser than -1. So what happens in our step 2? In step 2, don't forget that in step 2 is where we are getting the number of connected devices. So in step 2 we are running this function here, get finger scanner count, so that once we get the scanner count, we are able to proceed with opening the connected finger scanner in the developer computer. But before we move to step 3, let me first show you the contents of the get finger scanner count function. So I'm going to do Control F, and then we go to that function here. So this is our get finger scanner count function. So as you can see, it is calling this ZKTeco API function called get device count. So get device count will get the number of connected ZKTeco devices and put it in our and put it in this variable that I created here, this int variable that I created here, and I am going to return this variable here as the count. Now if we go to our console, you will be able to see that we are able to receive this message here and with the count of the connected ZKTeco devices. So let me quickly show you this in our console application, how this message was, what was the count of the connected ZKTeco devices. So you can see here number of connected ZKTeco finger scanners is 1. So this was as a result of this bit here, line 133 here. Number of connected ZKTeco finger scanners is this variable here, which is retrieving that value from our ZKTeco API function called getDeviceCount. So far so good. I've been able to show you how to initialize the ZKTeco API in step 1 and how to get the number of connected devices in step 2. Now we will need to go to step 3 so that I can show you how to open the device before you can be able to proceed with other steps of doing finger capture. So now here we are in step 3. I'm going to show you how this bit worked. So in step 3 we are going to open the finger scanner. Now we have this variable here where if it is an int, by the way, if it is greater than 0, we are going to carry out these steps here. So the first thing, suppose we have 2 ZKTeco devices connected to our computer. We are not going to use 2 because this is just a simple application. We just need to use only 1. So in case someone has connected more than one ZKTeco device, that is 2 or more, I will show them this message: connect only one ZKTeco scanner. Connect only one ZKTeco scanner at a time, because we don't need to go through the struggles of handling more than one device, because this is just a simple application. But if you want to use more than one, you can adapt your code so that you can be able to select which of the connected ZKTeco devices that you want to use. So in my case, if the developer is using more than one, I'm going to call return so that the application does not proceed any further and it actually stops at this bit. But if it is only one ZKTeco device that is connected, the application will be able to proceed to this line here and open the finger scanner. So in our case, the application was able to open the finger scanner by running this function here. That was possible because we only connected only one ZKTeco device on the developer computer. Actually, I have only one ZKTeco device, that is a ZKTeco 4500 fingerprint scanner. I don't have any other ZKTeco device with me. Now, to show you how this open finger scanner function works, I'm going to do Control F so that I can take you straight to this function here, so that I show you the contents of the open finger scanner function that is able to run our step 3 activity, that is to open finger scanner. So I'm going to go straight into this function. Now, what is happening right here? So this function of ours is taking in the device that we were able to retrieve after getting number of connected devices. Let me take you back so that I can show you that bit. I hope there's a way I can go back. How do I go back? Okay, do not forget that we were at line 138. So let me first take you right here in step 3 so that I show you what is happening. So in our case here, we are inputting this device here. We are passing as an argument the value of the number of connected devices. So if you remember very well, you see, if I double click on val res count, you can see it is the same one where we are getting the get finger scanner count. So the get finger scanner count, the value from get finger scanner count in step 2 is going to populate our val res count int, and if it is only one, not more than one, then we are going to pass it into our open finger scanner function. So now let's go to open finger scanner at line 138. Don't forget we were at line 138. So at line 138 open finger scanner function, we have our val res count, if you remember. So it is this one here that we are going to retrieve it in as ZKdev. And then because our API sees the number of connected devices, it puts them in an array. So we are going to do -1 because our array starts at 0. So in our array we say 0, 1, 2, 3. So we are not going to pass 1 here. Otherwise, if we pass 1 here, it is going to assume we have 2 devices. So since the array begins at 0, we are going to do -1. So that's why I'm doing ZKdev -1, so that I can pass that as the ZKdev index. So if you have 1 scanner, your ZK index is going to be 0. If you have 2, your ZK index is going to be 1. If you have 3 devices, your ZK index -1 is going to be 2. So don't forget that bit. So in this case, because we have 1 and this is going into an array inside the ZKTeco API, we are going to say -1. So ZKdev -1 is going to be 0. So in our case, ZKdev index is going to be 0, and that is the first item in our array inside the ZKTeco API. So that is what we are going to pass here in this open device function of ZKTeco. And then that is going to give us a handle. By the way, this is a unmanaged code in C, but now since the integration is in C#, we are going to, this is how we are actually calling the, this is how we are actually retrieving the device that is connected, and we are then passing it through the open device function of the ZKTeco API, so that we can pass a handle to it. So this handle is the one that we are going to be using to interact with the open ZKTeco device. So now, to get us started, before we get to use the handle, we first need to check whether it is a null, and this is how we are doing it in C#. So we do this to confirm that it is not a null. If it is a null, we return opening ZKTeco device failed, because it means our open device function did not manage to pass us a handle to the device. By the way, I need to put a return here so that it doesn't proceed any further if it notices that the handle is null. So let me just type return here. Yeah, it doesn't need to proceed any further if it is null. Else, then it returns this message here, opening ZKTeco device success. So now in our case, since this step was successful, we were able to pass a handle after opening the device to the mdev handle. We received this message that opening ZKTeco device opening ZKTeco device success. Let me show you that bit in the console. So here is that bit, opening ZKTeco device success. Otherwise, if there was no ZKTeco device that was connected into the developer computer, we would have received a fail, or if the ZKTeco device was malfunctioning, we would receive a fail here. Or if we had another device that is not ZKTeco that cannot be communicated with via the ZKTeco device, we would have also received a fail. But in our case, since we have a genuine ZKTeco device and we were able to open the device, that is why we were able to receive this message here, opening ZKTeco device success. Now, so far I've been able to show you step 1, how to initialize the ZKTeco API. Then step 2, I've also been able to show I've also been able to show you step 2 on how to get connected device. And in step 3, I've been able to show you how to open the connected device. Now, let's go to step 4. And I'm going to minimize this console here. Then I reopen. I get back to Visual Studio IDE. So in step 4, I am going to show you how to get the width and the height. Is that the case? The width and the height of the fingerprint scanner image. So the first thing you need to do, okay, this one is not going to be simple to explain, but your ZKTeco API, we have just lost electricity. Welcome back again to the continuation of this episode. The day before, when I was recording this episode, there was a power outage, so I couldn't continue, but let's resume. Now, going back to step 4, that is where we are getting the fingerprint scanner image width and the height dimensions. Now, if you remember very well from the previous steps, we first initialized the ZKTeco Fingerprint Scanner API in the first step. Then in the second step, we were getting the number of connected devices. In the third step, we were opening the connected device and then retrieving a handle for it, so that we can be able to use that handle to carry out any other operations, any other fingerprint related operations. Now, in step 4, I'm going to show you how to get the fingerprint image width and the height, so that with the image and the height of the particular image that is captured by your fingerprint scanner, you can use the image width and the image height to create a buffer for the fingerprint image. What I'm saying is that you need to know the size area of the plane of your fingerprint scanner, so that with that area you can use the fingerprint area value to create a byte buffer for your fingerprint image, because various ZKTeco devices will have different areas of the platen area. The platen area is where you place your finger on the fingerprint scanner so that it can be scanned. Some have a small area, others have a wider area. So to be able to preserve enough space for where the fingerprint buffer bytes are going to be stored, you need to get the image height and the image width. So right now I'm going to show you how to proceed with this. And another thing, before I forget, to be able to get the width and the height of the image, you need the device handle. So the device handle is the one that we got when we opened the finger scanner device. So the main purpose of opening the finger scanner device is to get the handle, so that now with the handle you can be able to get the image width and the image height and be able to carry out other operations that you need to do with your fingerprint scanner, e.g. capturing of the fingerprints, or enrolling fingerprints, or capturing fingerprints for the purpose of verification or identification. So now that I've been able to review the past steps that we have already covered, now we can move to step 4, so that I show you how to capture the fingerprint image width and the fingerprint image height from the device that we have connected to and the device that we have opened. So I believe up to that bit I've been able to clarify I've been able to clarify what we need to do right now. This one thing that I remembered, I needed to show you the the API document. There is a part that I need to show you for the ZKTeco API document. There is this bit here in the error codes. I know you have been seeing this in the code, this bit here, this ZKFP underscore error okay is equals to 0, which implies that the operation was successful. So anywhere where you see in the code I have used ZKFP underscore ERR underscore okay, that means the operation that I'm checking, I'm actually checking for the success of that operation, because if that operation returned as 0, it means the operation was successful. So that is what I wanted to show you before we continue. I realized that I had not mentioned this earlier, so let me minimize this. How do I do it? Minimize. Yeah, so now let me take you straight to step 4, so that we can begin this process so that I can begin to show you how we are going to get the width and the height of the ZKTeco fingerprint device that we have connected to, and the one that we have opened and retrieved its handle. So one thing that I need to inform you is that this is the C# code calls a wrapper. The C# code is a wrapper. What am I saying? This C# code right here in this entire C# code here, behind the scenes, it is actually C, because ZKTeco first did their API in C, and then they created a C# wrapper to enable C#.NET and other .NET developers to be able to interact with the API of their ZKTeco devices. So in this case, we are not able to get the width and the height like just off the, is this the correct word to say, like just off the hook, like, you know, okay, this is the height, this is the width. This is because in C things are done differently from, some things in C are done differently from how they are done in C#. So why am I saying this? For our case here, we need to retrieve the height and the width as a byte array, sorry, as a four sized byte array. So that's why we have this param value here, that is a byte array of size 4. To be able to get the int, the width and the height as int, we will need to convert this byte array value into an int, that is an int that will be able to depict that will be the pixels that we need for the height and the width. So this is the purpose of us having this param value. So we will reuse it the first time for getting the width and the second time for getting the height. So the size, we also have the param size here, which is 4. In other words, I could have just replaced this 4 with param size. Okay, now let us get started with getting the image width. So I came up with this variable here that I'm calling resval width. It is an int. It is going to receive the value that we will get from calling the get parameters function of our ZKTeco API. So this is the method definition. Let me hover over it so that you can see the definition. So as you can see, we need to pass the device handle, and we also need to pass a code, and the param value, this is what we are going to receive, and we will also need to pass the size. So in our case, the device handle, we already know. The code here is this that you're seeing here. Sorry, just one moment, I just knocked off something right here. I need to correct it. So for the code, okay, sorry. So for the code is this value here, this one here. So this is the value that is representing the width. I'm going to take you to the top so that you can see it. Here it is. So if it sees code 1 in the get parameters function, it will know that it is required to get the width. Similarly, for height, if it sees code S2, it will know that it is being required to get the height. So to make things much easier and and much simple for doing follow-up, I decided to come up with these constant int variables here, then so that I can assign them those values, so that you just don't see a 1 and you don't know what it is doing, or you see a 2 and you don't know what it is doing. So for width, I created this one here and then assigned it a 1, and for height I created this one here, this const int here, and assigned it a 2. So I hope you'll be able to remember that. So let's move on to line 61 right here. So remember, right now we're in the process of getting the image width. I need to scroll this to the left so that you can see this bit here. I even move further to the left so that I show you everything. So if in our get parameters function, we will need to pass in the handle, that is the fingerprint scanner handle. This one we got it from that time when we were doing a open device, and now this one here is for is the value that we are passing in inside the get parameters function, so that we know that we are in the process of retrieving the width. So remember, this is supposed to be a 1 implying width, and then this is the parameter value. So this ZKTeco API code is calling C code in the background, but then it can't just return the int. It will return a byte array, this one here, as the width. Then for us, we will need to convert this to int so that we can get the width of the image. Okay, as for param size here, this one is 4. This is the size of the byte array, this one here. So you remember we declared our byte array for param value to be 4. So this param size here, the int 4. So we could have instead of just putting 4 here, we just put this param size here to imply that our width is being returned as 4 bytes in an array. And for those 4 bytes, for those 4 bytes, we need to convert them to an int, so that we can be able to get the pixels of the image width. Now that I've shown you how to get the width, remember I told you that we will be able to pass in the device handle. Then this is the value that tells the get parameters that we need. We need to get the parameter value for width, and this is the byte array, and that this is the size of the byte array. So this is going to be what did I do now? So this is what we are going to get. Will be the output. This will be the output, and this output is what we are going to pass inside this function here, byte array to int. So we pass the byte array, that is the param value, the 4 byte array, the param value here, and then our output is going to be this fp image width. Let me show you where I had this at the very top. You see this? So I had already come up with this int value here. So at the very start it is a 0, but once we call this function here, byte array to int, and we pass the param value, it is going to be able to retrieve for us the fingerprint image width as an int. This is actually a ZKTeco API function. Though you could even do yours on your own, you do the conversion by yourself, but there's no need if you prefer to use the ZKTeco API function for converting the byte array output into an int. So now I've been able to show you how we are getting the width, and if I go back to the console, okay, just before we go to the console, let me first show you how to get the height. So for the height, for the image height, we'll also need to do the same. We call the get parameters function from the ZKTeco API. Then we pass the device handle, and then we also pass the value that tells get parameters that we are looking for the height. So this one is a 2. So if you pass a 2 here, you get the height, and then our output is going to be this byte array here. It is going to be returned as 4 bytes, and then this is the parameter size, which is 4, 4. You can see 4 from here. So what happens after we pass that? So we are going to the output is going to be, we are going to receive 4 bytes in an array, in a byte array, and then we will pass that into our byte array to int ZKTeco API function, and then we are going to receive the fingerprint image height as an int. So let me take you to the very top here. You see how I had declared it at the beginning. So at the beginning I set this to 0, but then once this function runs, once we run this, we get the parameters. I mean, we run this get parameters function here, then we get this value here, the params value here, and we pass it here. This ZKTeco API function is going to populate the FP image height int and give us a value for the height. So let me show you something here. I need to show you the width. I need to show you the width in the console, and I also need to show you the height. So in our console right here, you can see that for this device, the device that we opened and got a handle to, it gave us the width as 292 pixels and the height is 374 pixels. Different devices will have different values for the width and the height. So far so good. I believe I've been able to explain that bit in detail. Now we are going to step 5. In step 5, we are going to allocate the space for storing the captured fingerprint image. So this space, it's going to be a buffer. So we are going to have a fingerprint buffer and a template buffer, but for this simple demo I'm not going to concentrate on the template buffer. I'm just going to concentrate on the fingerprint buffer, and then I also show you how we are and then I also show you how we are creating the image from how we are displaying the captured fingerprint image that is stored as a buffer immediately the fingerprint capture process completes. So now moving on swiftly, we are going to step 5. In step 5, we will use the width, the fingerprint image width and the fingerprint image height to create a fingerprint buffer. So what are we going to do? So the first step, the first thing we will do is we are going to create a variable here that is a fingerprint buffer, a byte array, and then we pass the size as the product of the image width and the image height. Now think of it this way. Think of a rectangular box that you need to get the area. So to get the area of that box where you're going to paint your image, you need to get the you need to get the width, and you need to get the width, and you need to get the height. So with the height and the width, you're able to calculate the area of that box area. That box area where you're going to paint your fingerprint image. So similarly, in our case here, we're going to pass the fingerprint image width that we got from step 4 and get the product of that with the fingerprint image height, so that we can get the area size that we are going to reserve for displaying the captured fingerprint image from our device. So this is the purpose. This is why we are declaring a fingerprint buffer byte array here, and then passing its size as the product of the fingerprint image width and fingerprint image height. Now if I take you back to the console, you can see that our width was 292 and our height was 374, sorry. So what do you think is the size that we are passing for our fingerprint buffer? So to do that, we'll just open the calc here. Sorry, what did I do? Yeah, this is our calculator here. Then we just do 292 multiplied by 374 and we get 109208. Is that real? Is that for real? 292 multiplied by 374. Yeah, so this is going to be our size. So in this case, new byte for fingerprint buffer, we could actually, instead of doing this, we could have just said new byte, and then when we are declaring the size of the byte array, we just pass this. Where is it ID? Yeah, we just pass this value here. But because we don't know what fingerprint scanner we will use, because today you could have a ZKTeco 4500, in the future you could have a ZKTeco 9500 or even another ZKTeco device. So to accommodate any other devices, to accommodate various other devices, the best way to approach it is just to get the product inside here, the product of both the width and the height. So you just specify the value here, so that even if it is 300 or another figure, it will multiply that and the one for height to get the size. Oh, sorry, what did I do now? Did I just close our... Okay, to get the size of our fingerprint buffer. Now I promised that I told you earlier that we will not be using the fingerprint template buffer, but for this case, because we don't need it for now, for this simple tutorial, we don't need to get into the details of the template buffer, but here it is. I also created a byte array for it and pre-assigned it 2048. So size of fingerprint template buffer is 2048, this one. So we could have, instead of just writing 2048 here, we just use this int value here and then we move it here to the top. But since we are doing nothing in this simple tutorial with in this simple tutorial, we are only going to concentrate on the fingerprint template, on the fingerprint buffer. We're not going to concentrate on template buffer for now, but in a future episode I'll be able to show you how we can retrieve the template buffer from the ZKTeco API immediately after finger capture. So now to summarize things in step 5, that is where we are allocating fingerprint buffer size using the image width and the image height that we got from step 4. I will show you the output of this bit here. So for the width, you could see that we are outputting the FP image width value, and for the height we are outputting the FP image height value that we got from step 4. So if I go to the console, you will see that this is what we got. For width, we got 292. I had already shown you this earlier. For height, we got 374. So if we could review things as of right now, from after going through step 1, step 5, you can see, I will remind you again that first, in step 1, you will need to initialize the ZKTeco API. Then in step 2, you will need to get the number of connected ZKTeco devices. Then in step 3, you will need to open the connected device and then retrieve a handle from the connected device when you open it. Now in step 4, that is where we were getting the image width and getting the image height for the purposes of creating a fingerprint image buffer. Remember the analogy of creating a box for painting an image, where you determine the area size by getting the width and the height. So in step 4, we were getting the image and the height for creating the fingerprint image buffer. Now in step 5, if you can remember, in step 5 we were allocating the buffer size. So we were using that analogy of the template, I mean, how do I call it, like the box for painting your image. So we were doing the allocation for fingerprint buffer using the width and the height, so as to reserve space for storing our fingerprint image in a fingerprint buffer byte array, so that when we do fingerprint capture, the image is transferred inside the fingerprint buffer. So I believe up to that step I've been able to clarify things in detail. Now we move on to step 6. This is now the most important step, where we are going to do capture fingerprint image. So to capture a fingerprint image, you will need the image, you will need the device handle, and you will need the fingerprint buffer where to store the captured fingerprint image. Now to show you this bit, let's go to capture fingerprint image function, so that I show you how these things, so that I show you how fingerprint capture process works. So I'm going to do Control F, and then we go to the capture fingerprint image. So here we are in the capture fingerprint image function. So I first created this variable here, and then created this while loop here. In this while loop, I am checking whether sorry, what am I saying? Yeah, in this while loop here, I am getting this bit here. I am calling this function acquire print, the acquire print function of the ZKTeco API, so that it can do fingerprint capture. And I am passing in the device handle, and I'm also passing the fingerprint buffer byte array. Remember the one that we reserved its size using the image height and the image width. And then this is for the fingerprint template buffer. Okay, it will retrieve it, but we don't need it as for right now, but you have to specify it so that this function can be able to populate it. And then once this API function for capturing fingerprints, that is acquire fingerprint function for, once this acquire fingerprint ZKTeco API function runs, we are going to check whether it was successful by comparing it against this predefined value in ZKTeco API. Remember this one? Let me just open it again for you so that you can see it. This one here. So if it returns as 0, we know that operation was successful. This one here. So if it is if it is not as 0, we know it has not yet succeeded in capturing the fingerprint scanner. So the fingerprint image. So here is not equal to 0. We know that it has not yet run that operation successfully. So that's why we will continue looping until we see it returns as 0. If it returns as 0, is where is it? Yeah, this one here. If it returns as 0, we know that operation has been successful. So what are the instances that will make it not return as 0? Now let me take you to the console. So you see, in this case here, where it was saying place finger on ZKTeco 4500 reader to scan, this message here, I hope you can see it here, place finger on ZKTeco 4500 reader to scan. So this time it is actually waiting for you to place your finger on the scanner. So if you don't place it on the scanner, it is not going to return, it is not going to show that the operation was successful. So only if the operation was successful will the code execution move outside this while loop. So before you place your finger on the fingerprint scanner, you will continue receiving this message here, place finger on ZKTeco 4500 reader to scan, this one here. So it will continue to show you this bit, until you place your finger on the scanner, and then that is the time it will give you this message. So this condition, when it returns successful, that will be when the acquire fingerprint function has returned a value that is equal to this predefined value here for success. Okay, so that way it will happen here. So once a fingerprint has been captured successfully, this condition will not be met, and the code will proceed outside the loop, and that is why you will receive fingerprint capture is successful. So I hope from that bit you've been able to see how the fingerprint capture is happening. Now, once the fingerprint capture has been successful, this message is shown: fingerprint capture is successful. Fingerprint capture is successful. And from the console, here is that message here: fingerprint capture is successful. And then from there we will need to display our captured fingerprint image. So now let's move to step 7. Remember that was step 6. Now before we move to, where is that function? Alright, just scroll all the way to the top. So I've been able to show you how, where is it? Yeah, here it is. I've been able to show you how we do the capture fingerprint image. Now not the last is going to be display fingerprint image. This is the function that causes this image to be displayed. If you remember well, when we did when I placed the finger on the fingerprint scanner, immediately after this message was displayed, this one here, the next thing you saw was this message here, and then immediately after that message you saw this image being displayed, the captured fingerprint image. So let's review the steps once more so that we are on the same page before I proceed to show you how the display fingerprint image functioning works. So the first thing you need to do is to initialize the fingerprint, the ZKTeco API in step 1. In step 2, you need to get the number of connected fingerprint scanners. In step 3, you need to open the connected ZKTeco device. In step 4, you need to get the image height and the image width from the device that you have opened in step 3. So remember, in step 4 we are getting the image height and the image width for purposes of creating and allocating a fingerprint buffer in step 5. So your fingerprint buffer size is the size of the product of the image height and the image width that you got from step 4. Now in step 6, that is the one that I've just shown you right now. That is where we do the capture fingerprint image, and you can see that I've been able to show you that once capture fingerprint image is successful, our fingerprint buffer is populated with the electronic data of the fingerprint image inside the fingerprint buffer byte array, the one that we reserved its size by getting the product of the height and the image pixels. Now on to step 7, where I will show you how to display the fingerprint image. Now there is one thing I need to show you, to tell you about before we proceed further in showing you how display fingerprint image works. Now in the previous versions of C#.NET that will use the .NET frameworks, you will use system.drawing to be able to access the bitmap, to create a bitmap from the bytes, the buffer, the electronic data inside the buffer, inside the byte array. But now for this case, because I'm using .NET 9, I needed to use this library here called ImageSharp. So ImageSharp works in .NET 9, and the previous system.draw, is it system.drawing or system.draw, the one that used to work in the .NET frameworks, that one will not work in .NET 9. So for .NET 9 I needed to add this ImageSharp library. So I added it, and I needed to also have this here, these 3 here, so that I can be able to manipulate the image and display it and convert it to other image formats such as PNG, BMP, JPEG, though in this simple tutorial, I'm only converting the fingerprint buffer byte array into PNG, and then I display it. So actually, if I just go back to this image here, you will see that it is a PNG. So it is first converting and saving it to PNG format here. PNG, I hope you can be able to see that, to a PNG format. Then it opens it. All that bit is happening in the background. So once the fingerprint is captured and display function is called, it saves the fingerprint buffer byte array into a PNG somewhere in a folder, and then it displays it. So the code itself actually displays the saved fingerprint image. So I don't have to save and then go back to the folder. So from the code, I just call the code to display the captured fingerprint image that was saved. Oh, I was just about to close that. Let me just minimize it instead. Okay, so what am I saying? So now I'm going to show you display fingerprint image function. I'm going to double click on it like this, and then I do Control F so that I can take you straight to the code, to the function. So here is our function. A moment please. I need to confirm something here, that I'm still recording this bit. Yeah, it's still recording. Okay, now in step 7, where I am showing you the display fingerprint image function code. So the first thing I need to do is to create the first thing I'm doing is creating this variable here, this image path string. And in this image path, I'm first initializing it with a null. So when the function starts, then the function is called, it first initializes this to a null, so that the previous image is not displayed. We just display the new image that we have just captured right now. Okay, so this image here, this variable image variable here, is in grayscale, that is black and white. So I'm creating this object here. I'm initializing it with the image width and the image height. This is like creating what do I call it? Like you want to paint an image on a white board. So you first make sure the board is white, and before you begin to draw your image on it. So in this case, is it a pastel, or what do you call it? I'm forgetting, but you just think of a whiteboard. So this is what this function is doing. So it is creating that new image box. Am I saying it right? Surely. But that is what is actually happening. So you remember the other analogy that I told you about for the finger buffer. So here, using the image sharp library, you are able to reserve a black, is it a gray area? Okay, 3 colors: white, gray. Is it 3 colors? White and black, let me just say that. Then you have that image object here. So this is where you are going to have your image inside. So you do that by passing the width and the height. Now in the next steps, this is going to now draw the image in your preserved board, the image board. So this is how it is going to do it. This is how it's going to do it. Do I need to explain this? You don't even have even the language for explaining it. Okay, so you just know that is what it is going to do. You can actually look up this on internet to see what it does, but it is simply drawing the image on a Cartesian plane of y and x axis, drawing it from the bottom, rather like painting it on this board, on this whiteboard that we pre-initialized. Okay, so once your image is drawn inside the image object, you will need to decide how you are going to save it. Are you going to save it as a BMP, a JPEG, a GIF, or a PNG? So to do that, you will need to have a path where you are going to save your fingerprint image. So in my case here, I am assigning this image path. You remember this one here, the one that was null initially? Then I am giving it this path here, and then I put a .png because I am going to save as PNG. If I was going to save as JPEG, I would have put a .jpeg. If I was going to save it as a BMP, I would have put a .bmp. Here you can just put whatever name that suits you, so that you can proceed with what is easy for you to remember. So now our image board, where we painted our image, where our image was drawn, we save it as PNG, and then we specify the path. So if you can check this name here, and if I open this, you can see this is the same name here, ZKTeco 4500 capture fingerprint image .png, like that. So that is our image, and that is how we were able to save it. Now after that, once it is saved, I did this bit here where I'm doing thread.sleep for 1000. So this is actually 1 second. The reason why I'm doing thread.sleep is so as to give this code here time to save the image before we begin to display it. Because imagine if you start to display the image before it is actually there. It is like opening a file that does not exist, and that will cause problems. It is like opening an image that does not exist, and that will cause problems. So I'm doing thread.sleep for 1 second, so that this code here finishes to save the image in the computer before it starts to display it. So now, before we display the image, we first need to confirm that the image path is not empty, is not null. So that's why I'm running this check. And if I confirm that it is not empty, the code will proceed to here. Then I will use this bit here, system. What am I saying? I will need to get the path. I'll need to get the path, and then use the shell execute to open the image with the default application for opening the application that I've set as the default for opening images. You see, it's like you have a file. If you save it as .doc and you double click on it, the default application for opening that document will be Word document, will be Microsoft Word. If you have a file, and then for example you have saved it as a .mp3, it is a music file. So if you double click on it, your computer will rush to open it with the default application that you set for opening audio files. E.g. in my case, it is a VLC multimedia player. So if I double click on an mp3 file, my computer will just rush to open it with the VLC because that is the default set application for opening audio files of MP3 format. So in this case, our file, our captured and saved fingerprint image is saved as .png. So our PNG, when it is a PNG open, when a PNG file is opened, it will attempt to open it as a photo image with the photo viewer. So that's why you saw the application open it with this image viewer here, image photo viewer. That is the default one for opening images inside the Windows computers. So basically this code, that is what it does. And once display fingerprint image function runs, it first saves it first saves the image, the fingerprint image buffer, into a fingerprint image format, that is PNG, and then it opens it with the default application, Windows application for opening PNG image files. Now let's review what we have been able to do so far. So that's all I needed to show you for display fingerprint image in step 7. Now once you're done with everything, you will need to your application will need to close the fingerprint scanner so that it is ready for use the next time you run the application. And also you also need to free the ZKTeco resources. So this is just explained in a simple way, but in the backend this is pure C code, and you need to free the pointers and everything and the memory allocations that were done in the backend. So this is the purpose of this function here, and you also need to do the same for the but first you close the fingerprint scanner and then you do the free ZKTeco resources. Now if we were to review what we have done so far, and then I take you through the steps again for capturing your fingerprint scanner. So the first step you need to do is to initialize your ZKTeco API. The second step is to get the number of connected ZKTeco devices on your computer. The third step is opening the ZKTeco device that you have connected to your computer and then get a handle to hit. The handle that you get in step 3 is the one that you're going to use to carry out any other operations that you want to do with your fingerprint scanner, e.g. capturing fingerprint image. In step 4 you're going to get the image height and the image, sorry, did I say height? Yeah, you're going to get the image height and the image width from your connected device. And then in step 5 you are going to allocate fingerprint buffer memory using the fingerprint image height and the fingerprint image width that you got from step 4. In step 5 you are going to, what are we doing in step 5? In step 5, yeah, in step 5 is the one for allocating, yeah, that is the one that I was discussing. Step 5 is the one where you allocate fingerprint buffer memory. You create that byte array, the byte array buffer. Then in step 6, that's where you capture your fingerprint scanner, and in step 7 you display fingerprint image. Now what I've not been able to show you is how to close the fingerprint scanner in step 8. Now let's just go to that straight away so that we can conclude with freeing the ZKTeco resources. So how do you close the fingerprint scanner? let me just double click on this and then I do Control F. So that is just simple code. Here it is. So in this bit here, in this function here, we are just going to call the close devices, and then we pass the device handle. That is the device handle of the opened fingerprint scanner. So we are going to call the close device function of the ZKTeco API and then pass the device handle so as to close that fingerprint scanner that we had opened earlier in step 3. And then once you are done, this device handle of yours, you null it. So once you pass this, it is assigned a null, but initially it had a reference pointer to that device. That is C anyway. That is a C. That is a, what am I saying? That is how things are happening in the very back end of the C code of the ZKTeco API, that the wrapper for C# is this wrapper for C# here that is calling in the back end to close the device. So I believe up to that far I've been able to show you how you close the device in C#. Now that was step 8. I need to show you how to do step 9 so as to free the ZKTeco API resources. So see, this is the function that I came up with for freeing the resources. Let's do Control F and then we go to it, and here it is. So once you call this terminate function in the ZKTeco API, it is going to free the resources for you in the backend inside the C code. So once you do this, our wrapper here, our C# wrapper that is handling the freeing of the resources in the C core code, will free the resources so that you do not have any issues with your fingerprint scanner with the leftovers remaining in the memory, or dangling pointers in the memory, so, or any other resources that are being used by the ZKTeco API. So once you call the terminate function of the ZKTeco FP API, it will free all the resources that were assigned by the ZKTeco API when you are initializing it in this bit here. Where is it? Yeah, when you are doing the init ZKTeco API. Let's go to it. Yeah, when you are doing this init here, so all the resources that were located during this time are freed by this. Where is it? It is hiding now. Yeah, they are being freed by, when we call this, they are being freed by this. So that's it. I know it has been a long episode, but the code itself is simple. It is just how many lines? It is less than 250 lines of code, so it is actually 222 lines of code. It is very simple. It just captures the fingerprint scanner. I mean, it just captures the fingerprint image, and it doesn't do more than that. But then in subsequent episodes, I'll be able to show you how to do more things, like coming up with the fingerprint template. The fingerprint template is the hashed code of your fingerprint image that you can save in a text file or in a database. So thank you for watching this episode, and thank you for tagging along up to this far. If you have any questions or you have suggestions that you would like to pass on to me, please drop them in the comment section. Let me know what you think about this piece of code. Let me know if you are able to replicate the same with your ZKTeco scanner. Let me know what your ZKTeco scanner width and height gives you. And if you need any help in regards to integrating your ZKTeco devices in your software application, I'll be glad to assist. You can check out the services that I offer to people like you and the prices of the various services that I offer on my official website, that is biometricsengineer.com. And if there is anything else that you would like to pass along, if there is anything else that you would like to let me know, I also have my email addresses there inside my official website, so you could actually send me an email in private, or just hit me up on my email and we discuss your integration and anything else that you think I could offer you as a consulting, and anything else that you think that my consulting services could help you with. I'll be glad to assist. See you in the next one. Bye bye.